Good afternoon, everyone, from me, Queanbeyan here in Australia, and good morning to listeners, particularly in Europe. Thanks for coming online today. First and foremost, I'd like to make it quite clear that we've gone to great trouble to make sure the quality of the presentation is better today and that the software works well. So hopefully there will be no troubles such that we've encountered in previous presentations. So Eva, if you could move to the second page, please.
Yes, second page.
So we'll be using the typical agenda for quarterly updates. So quarterly report highlights, the commercialisation schedule, a focus on corporate and financial progress, highlights in relation to research and development for the quarter, in particular our TAB milestones, touch on manufacturing and technical collaborations, and finally financials, and then over to you for any questions, which of course we always welcome. Next page, please, Eva.
Yes, page 3.
So the highlights for the quarter were many. First and foremost, we were awarded a $2.5 million grant from the Department of Industry, known as a Cooperative Research Centre project grant. We managed to achieve a number of Technical Advisory Board milestones. First and foremost, a thermal cycling milestone, which is a legacy issue from a previous quarter in relation to glass modules. The current milestone for the quarter, which was in relation to our European-based metals project. And moving on, in conjunction with Science, we achieved a world record for roll-to-roll or reel-to-reel perovskite solar cell production of 12.6%, which was extremely encouraging. And finally, we completed phase 2 of the very important VDL major area demonstration prototype project. Next slide, please, Eva.
Page 4, yes.
So this is the commercialisation schedule, and just to touch on the key aspects of it, during 2016 and 17 we are working on both prototyping and pilot line development for glass, and in relation to metals, they lag the glass development by 1 year. So this year we'll be beginning to focus on prototype work at Science for metals, and we're confirming our commercialisation schedule today. Next slide, please, Eva.
Yes, page 5.
So just to give you a little more detail around the nature of our grants in particular, so the CRC-P grant was for $2.5 million, of which the lion's share of that grant goes to Dyesol of $1.9 million, with $0.6 million going to the CSIRO, and CSR being having a relatively minor role at this stage, but providing glass free of charge, and also helping with logistics and involving as a formal participant in the CRC-P grant. So we're in the latter stages of preparing for signing of the participants agreement, and that's expected to be signed off by both CSIRO and CSR boards over the next few days. Of course, having 3 key operators in this consortium allows for discussions around co-location. It brings to the consortium glass and glass handling expertise, and also is a great opportunity for ongoing commercialisation discussions. We're currently discussing with various state governments relocation opportunities for this project and establishment of a dedicated prototype facility in a major state capital with access to both port facilities and potentially glass for both import and export. So there are some opportunities available at the state government level for assisting with financially for relocation for some of our staff here from Queanbeyan to a state capital, and we're taking advantage of that opportunity, and we've already engaged in serious discussions with state governments in the past few weeks. So that's something we look forward to reporting on as we go forward. Obviously, Melbourne is a lead candidate, given that CSIRO's principal perovskite-based activity is at Clayton in Melbourne, and also just down the road we have CSR at Dandenong, so where we expect to source our FTO glass from. So obviously that's a lead candidate, but there are also other opportunities, particularly now that New South Wales is offering very generous financial assistance in the renewable energy space. That's another opportunity that we are considering. Moving on to Commonwealth grants, we have been talking for some time about ARENA. I don't want to actually address ARENA in detail, other than the fact we're in advanced discussions with the Commonwealth Government at the moment in relation to very significant grants, which will feed into basically our prototype projects, particularly in relation to glass. Of course, I don't want to jeopardise those discussions, and obviously it's important to establish a strong bond of trust between Dyesol and government. But I am happy to report that those discussions are in an advanced stage, and it was also quite telling yesterday that there was a new publication or news item from ARENA discussing changed investment priorities, which would seem to indicate or put us in paint us in a very favourable light. So rather than focusing on funding of existing or established renewable technology, ARENA yesterday published a change of priorities, indicating that I'm now focusing on new innovation, which is a category into which Dyesol would comfortably fall. So we look forward to giving you an update on the advance of any Commonwealth-related grants over the next few weeks, but and months. But that release yesterday from ARENA was particularly encouraging. In relation to ongoing funding, it's something that we have a formal policy in not giving any detail to the market, other than to say that we are currently focusing on some interesting opportunities both in non-dilutive and strategic investment. We're very confident of our cash flow outlook, and it's not an issue or something that we would comment in our quarterly. Suffice to say that a mixture of grants, potential strategic funding, and of course we're getting towards the end of the financial year, and we expect to recover somewhere between $3.5 and $4 million this year in R&D rebate, which is a very important source of funding for us, which significantly ameliorates our gross spend, bringing our net spend down for the year into the vicinity of something like about $600,000 per month. So very comfortable with that position. If we could move to the next slide, please, Eva.
Page 6.
So just moving on to R&D, just to give you a little bit more colour around our R&D activities for the quarter. At the end of March, we attended what's known as a technology retreat in Macau. This is not because we like to roll the dice. And as we know, the great scientist Albert Einstein once said, "God doesn't play dice." But Macau is a wonderful location for us to bring together a number of our key global scientific leaders. Notably, that includes Damien Milliken, our CTO, but also from Lausanne, our Chief Scientist, Dr. Hans Di Silvestro, and also Chris Moore, who oversees our UK and European operations. There we confirmed our technical risk management strategy and lead candidate architecture for commercialisation, the porous carbon design. Very fortunately, work conducted at Soliance is also providing additional options, especially with such promising efficiency results recently being achieved by Soliance. Lab performance, for example, for what's known as the PIN configuration is approaching 18%. Of course, work conducted there is for metals or flexible substrates, but it's very promising and may have even broader applications for both glass and flexibles. So we have a lead candidate known as porous carbon, but we're also running with a PIN configuration, or for what is more generically known as a planar configuration. So we have a number of options going into the mini-MAD and MAD prototyping phase in order to maximise performance and to constantly play off both efficiency and stability performance from both architectures to make sure that we bring the best product possible to market as a Gen 1 product. Next slide, please, Eva.
Yes, page 7.
So just touching on the TAB milestones in a little bit more detail. So the legacy milestone from the previous quarter related to thermal cycling. Thermal cycling is effectively taking modules from minus 40 degrees C to plus 85 degrees C through a number of cycles, in fact up to 200 cycles, which takes approximately 7 weeks to conduct. We conduct these tests both internally, but for the importance of external validation, we also work closely with CSIRO to perform similar tests. So while we achieved positive results in the previous quarter at the strip cell level, we've now actually achieved those results at the 10 by 10 module level, and we passed with flying colours. So we're very pleased with that. And that work, which was validated internally, has also been externally validated by CSIRO. Thermal degradation is part of the IEC 61646 accreditation standard. If you can imagine, it's a particularly harsh test for accelerated weathering or aging, and it's something that you would never really encounter in real-world conditions. But to pass that is a very important achievement for us in ticking off yet another IEC 61646 test, and takes us further and further towards commercialisation. So very happy with that. Moving on to the next milestone, which was for the current quarter, and again is subject to the scrutiny of the TAB, or the Technical Advisory Board, which is chaired by Professor Gratzel and also attended by Dr. Rob McIntyre, who's effectively the TAFNI representative on the board. We comfortably achieved the quarterly milestones, which related to efficiency targets for flexible substrates. It's probably the first time that we've actually introduced some of the work we're doing in the UK and Alliance to TAB milestones, but it's also good to know that we're making very good progress there. Working with flexible substrates has individual challenges, particularly because we're working with opaque substrates, which means that the actual configuration is what we would describe as a backlit structure rather than a front-lit structure. And it's effectively the real stack to what we would use with glass. And it was very, very encouraging for us to comfortably achieve 9% on strip cells on steel. And given the fact that our partner there is now achieving up to 12% on similar configurations, we're very comfortable with moving forward towards 12% ourselves. You may ask why there is a differential. Our focus is on using not the same but similar materials. Our focus is far greater on stability. So we typically use inorganic materials rather than any organic materials, and the 9% was achieved with an all inorganic structure. And as you know, the promise of inorganic materials is such that we can head towards 5, 10 and perhaps at a later date 20-year life for our products, which is very important in bringing a product to market. So that's particularly encouraging for us. And there was one final milestone, which is an internal milestone that I'd like to touch on, which was an outdoor testing exposure milestone, which is also part of IEC, which wasn't a formal TAB milestone, but one we conducted internally, and we also satisfied that test. So for all intents and purposes now, we've covered off on all the IEC 61646 milestones at the module level, and we now intend to progress those to working at larger scale for glass devices, which at the mini-MAD scale for glass devices and beyond. And at the flexibles or metal stage, we're moving now from strip cells onto stability testing at large device level as well. So making some excellent progress there, and hopefully that wonderful schematic on the slide gives an indication of just how confident we are now of pushing forward regardless, and taking this technology towards commercialisation, albeit in a very managed way. So next slide please, Eva.
Yes, slide 8.
So just to touch on any developments in the quarter in relation to manufacturing collaborations. So principally as an internal project, we're working both at mini-MAD and MAD levels, which of course stands for Major Area Demonstration Prototype. We've now made our third batch of mini-MAD panels, and we're working relentlessly towards a better mini-MAD and optimized panel, particularly in improving the active area and working with better and better tools. So all the work there is very encouraging and meeting internal targets. As I touched on before, we've now finished phase 2, or the engineering and design phase of the VDL Major Area Demonstration Project, which allows us now to commence phase 3, which is realization and testing. So we have all the necessary information, we've chosen the suppliers, we've fully costed the project, and the costings in that project feed directly into a number of the major grant applications that we currently have outstanding in Australia in particular. So we're very, very comfortable with having a significant part of that MAD budgeted, funded by promising and imminent grants. So that's all very exciting, and also we've also engaged in discussion with VDL this week to begin feasibility work at the pilot line level. So pilot line is effectively taking a prototype project and subjecting it to automation. It doesn't actually encounter a significant additional budget, given the fact that the tools that we use in prototyping are what we described as automation ready. But it still requires feasibility as part of a de-risking process. So while we're working through the MAD prototyping phase and sourcing equipment, VDL will be working very intently on the next major step for Dyesol, which is moving on to a pilot line phase. And VDL, as you're world experts in both automation and robotics. So that's a very exciting discussion, and that work will commence almost immediately at VDL in Eindhoven in the Netherlands. Moving on to, I guess, the third box there. I don't want to add a lot to Turkey other than it's quite obvious to everyone that Turkey's going through still quite a lot of political change. According to our partners, the political change is positive and will bring about greater economic and political stability to Turkey. So we're confident moving forward. At the moment, we are reaffirming quite a number of our financing commitments, both at the ministry level and also at the Turkish development level. But you know, it's been a fairly long-winded project, interrupted by events beyond our control, but Nestle seem very confident that ultimately we'll bring that project together. And of course it has enormous potential, given that that the dynamics for introduction of new renewable technologies in Turkey are very positive. Elsewhere, of course, one thing that was highlighted by our exposure to Turkey was the fact we needed to work more aggressively on developing other opportunities. In late March, at the invitation of the Chinese government, we attended meetings in Beijing. In fact, there are multiple opportunities for us to discuss commercialization of our technology in China. It's something we've always been quite cautious about, given that China has been historically somewhat notorious for not necessarily respecting global IP laws, although in recent years most companies I speak to become more and more confident about establishing joint ventures in China and respect for IP. So I'm pretty confident that we'll move forward in those discussions with multiple partners. It does indicate to me on a more macro basis that China is becoming more and more more and more disappointed with operating in the first and second generation technologies, and in particular in the former, as we know that the margins for profit have become more and more slender, despite the fact that the market continues to grow aggressively, and in 2016 was estimated to be as high as $75 billion US. So what we want to see is our technology commercialised by multiple international partners, and also here in Australia, and also see this technology differentiated on something other than cost. Of course, as we know, the projected costs for this technology are very low, but it also has the added benefit that it is also versatile in terms of some of the additional geographies that it can address, but also additional applications such as building integrated photovoltaics, which is something which Dyesol has always promoted. And it will be very interesting to see what Tesla does in this space over the next few months, because we still harbour some reservation about Tesla to develop a viable product into the BIPV sector. So anyway, we laid down that challenge to Tesla, and quietly behind the scenes we're working on our own products to provide over time something which we believe will be highly competitive, both in terms of its use in multiple applications, but also in multiple geographies, and also at very low LCOEs. It's very exciting to think of the opportunity, and we like to think that the concept of buildings as power stations, particularly industrial warehousing, is something which is alive and well, and is a very exciting opportunity for us. Moving on to the financial slide, which is the next slide, or slide 9, please, Eva.
Yes, slide 9.
So it was an unremarkable quarter in relation to gross and quarterly burn, and as I said earlier, we will recover somewhere between 3.5 and 4 million Australian dollars from the R&D rebate at the end of the financial year. And it's also good to mention to you from a financial discipline point of view that for the last 3 quarters, or for the financial year thus far, we're operating well within budget. So in particular, we've managed our foreign exchange exposure well, and we've also managed our spend very tightly. So we're going into the financial year of FY18 with great optimism, and you know, on budget and on schedule. So if I can just turn to the 10th slide, which really is more about our communication, not only this quarterly conference, but you can also follow us, of course, on Twitter and on LinkedIn, and I'm pleased to report we've also uploaded our German translation of the 3rd quarter report onto our website today. So for those of you who wish to read this in German rather than English, then it's available to you today. So on that note, I'll hand back to you, Eva, to pass on any questions from the audience.
Yes, thanks a lot, Richard. Vielen Dank. You have now the possibility to ask questions via the chat. Sie können nun Fragen stellen via Chat. Das ist rechts unten. You find it on the right bottom of your screen. Ich habe auch bereits ein paar Fragen erreicht. I already received a few questions. The first question is, with DSC, you expected your markets are in areas with cloudy weather, like Europe, for example. Where do you expect your markets with perovskite?
That's a very good question. Perovskite solar cells, like Dyesol cells, do enjoy what we know as a real world premium. So they tend to perform closer to their nameplate specifications compared to, say, 1st and 2nd generation technology. So we've published some preliminary results on the stock exchange 2 months ago, which demonstrated that the performance of perovskite solar cells demonstrates a yield improvement somewhere about 15% relative to, say, silicon. So we are regularly testing silicon and perovskite solar cells here at Queanbeyan, And in real-world conditions, which of course encounter cloud in particular, but in other parts of the world may encounter things like haze or pollution, our technology is demonstrating that it's performing better in real-world conditions relative to silicon, and similarly to say what Dyesol cells performed. So this does, of course, open up opportunities for introduction of this technology as a market entry strategy into environments where silicon at the moment is proving to be particularly unsuccessful. So in the absence of subsidies, for example, in Northern Europe, we see very little silicon activity. We are confident that this technology could be introduced and produce commercial yields and be viable in places like Northern Germany or the UK or Scandinavia or parts of North America, but with very little competition, just because of what we have described as our real-world performance premium.
Mm-hmm. Thanks so much. And maybe I'll just pick out a question which directly fits to this question. What are the advantages of perovskite against silicon, and what are the disadvantages?
Well, the principal advantage is that estimated costs for perovskite sols are significantly lower at similar scale than silicon panels. So silicon panels are currently valued at around 50 US cents per watt peak. And of course there is some projections that this price will fall lower over time with greater scale and improvement to techniques. So we can't discount the fact that silicon will also improve. But I'll draw your attention to a paper published in 2016 by the National Institute of Material Science of Japan, where the forecast for this technology is to produce panels on a watt peak basis as low as 20 to 25 US cents. And this is because the active materials in perovskite solar cell panels are very, very cheap because of their abundance. And we use very, very little quantity because we apply the materials in ultra-thin layers. So the actual cost of the active materials in a meter-by-meter perovskite panel are forecast to be in the vicinity of $1.50 US, which is significantly lower than silicon cells or silicon panels. And of course, we don't use high temperatures or any form of vacuum, which is part of either first and or second generation manufacturing processes.
Mm-hmm. Thanks so much. Then a financial question: when will you be in a position to provide revenue forecasts with the commercialization of both glass and metal?
Well, making forecasts is largely governed by the rules of the stock exchange, and we don't consider that we are in the position to make forecasts in relation to the commercialization of our technology at the moment until formal commercialization partnerships have been established. So I'm unable to comment on that, but I feel very confident that if we have a knockout technology which is significantly better than the incumbent technology, then it'll only be a matter of time before we establish commercialization projects in countries like Australia, Korea, China, and potentially Turkey, where we can begin to make some form of financial projections. Financial projections have to be, of course, based on reasonable grounds, and until we really fully finance and establish manufacturing capability, it is difficult to do. But that is something we'll be addressing in more detail towards the end of 2018 as we move towards commercial production.
Mm-hmm. Thanks so much. And a question regarding Turkey. Is it possible to give an idea regarding the time schedule in Turkey?
Well, I've tried to, it's a challenging question. I've tried to make projections or forecasts based on information I've received in the past from Turkey, even such that the information's come from the higher echelons of government. But as you all know, Turkey's a very challenging country in which to do business at the moment. So, and given the fact that I don't have a crystal ball, I'm reluctant to actually make that forecast. But most importantly, the takeaway from this discussion is that we're not reliant on Turkey. And if we do decide to form a manufacturing joint venture in Turkey, it'll be done on a very strict risk managed basis. We don't wish to expose the assets of Dyesol to undue to political turmoil, and of course we need things in Turkey to settle down so we can have a better idea of what the future outlook for Turkey is. But as I say, the feedback I get from my partners is that the most recent referendum held in the last few weeks in relation to presidential powers that will restore or bring greater stability to Turkey. It's also important to note that there are actually hundreds of billions of foreign dollars invested in Turkey, and during this period of this period of political turmoil over the last 10 months, it's never come into question the ability for foreign companies to transact business in Turkey. There's been very little restriction on, or no restriction that I'm aware of, to companies to move capital in and out of Turkey. So despite the news headlines, it really is business as usual in Turkey. But we will proceed with great caution, and you know, we spent a lot of time speaking to our counterparts in Turkey, both at the Nestle level, but also in government, to make sure that we fully understand what the prospects are for commercialization of our technology in Turkey.
Mm-hmm. Thanks so much. And maybe another question regarding regions. In the past, you worked together with Pilkington in the US. Do you have any further plans to work together with US companies again?
That's a good question. I think the US is probably a little behind the rest of the world in addressing the opportunities in solar generally, and in particular third generation solar, because as you'll be aware that it's had the great benefit of very cheap coal seam gas, or coal shale gas as they describe it, over the last 5 years. But we are starting to see some interest coming in from the US. We work closely with the NREL in relation to them developing testing protocols for this technology, for example. So I do see some potential, and we've also opened discussions in the last month with a US-based technology provider that we're working with to develop what is known as photocatalytic cleaning of solar glass. So we will be potentially introducing some US-based technology to assist with improved performance in our panels. It's for incremental improvement. It's not for significant improvement, but it does indicate that that technology progress in the US in solar is beginning to improve again. I guess people are somewhat a little hesitant about what might happen under the Trump administration, but as we're really seeing in the last 100 days of Mr. Trump's presidency, a lot of the perceived threats have not actually come to fruition. There's no sign of the Mexican Wall, and there's no really material change to energy policy at the moment. So we're quietly confident of establishing further ties into the US, but it's not a priority. Our priorities are focusing on Europe and more recently China and Turkey, where we've been nurturing or cultivating interest in our technology for many years. So it's a matter of basically addressing and prioritizing opportunities, and as the proverbial saying goes, you can't kiss all the girls and boys.
Okay, good to know. And
You can only try.
Okay, there's a further question regarding the different sectors of Dyesol. Does Dyesol expect to sell in the future more materials or more whole solar panels? Where do you expect the revenue stream in the future?
That's another very good question. Dyesol's involvement in material manufacture serves several purposes. The principal purpose is to satisfy our own need for materials. It also helps subsidise our burn rate because it's a profitable business, albeit growing at an annual rate of around 10%, and over time transitioning from DSC-related materials more and more to perovskite-related materials. But it also provides us with a significant IP control. It's our intention in all our joint ventures to supply materials into those joint ventures and maintain control of material manufacture. Materials involve quite a good degree of IP, not only in the form of patents, but also in know-how in relation to processes and trade secrets. So it's an important IP block, and while it's not necessarily significantly profitable, it's one way of maintaining a strong barrier to entry. Going forward though, our principal avenue of growing revenue will be involvement in joint ventures and owning a slice of production. So it's our long-term intention to form joint ventures in the countries that I've described today and to own a minimum of 50% of those manufacturing projects to generate significant revenue for our shareholders. And this is not a niche technology. This is a technology which is highly disruptive, and over time we believe it has the ability to compete strongly with first and second generation technologies and own a significant slice of what is currently a $75 billion market.
Mm-hmm. Thanks so much. And the further question is regarding perovskite and metal. In the past you planned to cover metal with Dyesol cells for the use to cover whole plants. Is it the same idea with perovskite?
Listen, the project that we've taken to Soliance has many similarities with the project that we ran with Tata Steel. As you know, Tata Steel, for many other reasons unrelated to Dyesol, has encountered financial difficulties, largely because of the inability to compete with Chinese steel manufacturers, which has made its activities in the UK unprofitable. But the project that we engaged in with Tata Steel in Chester, or in Shotton in North Wales, was a great learning experience for us, and many of the processing steps that we developed in that particular process or project we've taken forward to Soliance. So the money and the lessons learnt have been invaluable to Dyesol. Most importantly though, that we've moved on from DSC to perovskite solar cells, and this technology is more durable than DSC in the sense that it uses only solid state materials, which means that we are very confident that it will be extremely durable and long life. And also the material set that it uses is significantly cheaper, which means we feel very confident of going head to head with first and second generation technologies and beating them on price, in addition to other advantages that the technology has. So Soliance are on board with this project, and we're working very closely with Soliance. Soliance, of course, used some of the VDL technology in roll-to-roll advanced manufacture, and we're working with that. As I reported earlier, we've also demonstrated now that we can manufacture perovskite solar cells on steel substrates in a continuous process, and that's extremely exciting and opens up the opportunity for mass manufacture for this technology, particularly for roofing products. And if you ever have the opportunity to to wander around Europe, you'll find that there's an enormous amount of opportunity for this technology on industrial warehousing, where just as an estimate, the level of penetration will be less than 0.5%. So basically, it's an open opportunity for this technology, which has not yet to be addressed by either silicon or for that matter, SIGs, either because it's too expensive or because it doesn't operate well in real-world conditions that you may encounter in places like northern Germany or the UK or Scandinavia or North America.
Mm-hmm. Thanks so much. At present, this was the last question, which I have on my screen. Maybe we wait just a few further seconds if I receive further questions. But at present, it does not look like. So, Richard, maybe we directly, because you anyway have to go in a few minutes, do you have a few last words you want to mention?
Well, I've said a lot, but I'm very excited about the prospects for Dyesol this year. I'd like to make it clear to the investors that the prototype project is very pivotal for Dyesol. We're working obviously with the best possible partners, not only with VDL, but more locally working with CSR, CSIRO, and increasingly with government. So we think we've got all the bases covered. So it should be a very exciting year for Dyesol shareholders. I know we've been very patient, but it's also been important that we haven't rushed in to commercialise too early, and we now have sufficient confidence now to be actually scaling up to prototype and pilot line level over the next 12 months, and that should bring a lot of value to Dyesol shareholders. So I thank everyone for their ongoing interest and attention, and as always look forward to speaking with investors in 3 months' time.
Mhm. Thanks so much, everybody. Ganz herzlichen Dank. Wir dürfen uns dann verabschieden und freuen uns dann, Sie in 3 Monaten wieder in der nächsten Webkonferenz begrüßen zu dürfen. So, Richard, I will stop the conference now. And
good afternoon and good morning.